Derivative of y equals sine of x from first principles. Y equals sine of x, that's the first point on the curve, where the coordinates are x and y. And the second point on the curve will be y plus a change in y equals sine of x plus a change in x. So that's first point, second point. Obviously, I want to take away the second point from the first point. So therefore, what I need to do is take my y and put it to the other side. So take away y from both sides. So I get delta y equals sine x plus delta x minus y. And now I'm going to replace y with sine x. So delta y equals sine of x plus delta x minus sine of x. In trigonometry, there's a trig formula which is sine of a minus sine of b, that be equal to 2 cos of a plus b over 2 sine a minus b over 2, where the a here is equal to x plus delta x, and this is the b. So that's a and that's b. So I'm going to place those values here. So that's sine of a. So delta y, 2 cos a is x plus delta x plus b, which is x, over 2 sine a, which is x, plus delta x minus x over 2. So I've just rewritten that, which is that, as that, where a is that and b is that. So I've just filled those in here. Now x plus x is 2x. So I get 2 cos 2x plus delta x over 2 sine x plus x minus x will be 0. So now it'll be delta x over 2. And if I write this properly, that will be 2 cos x, 2x over 2 is just x, plus delta x over 2 with delta x over 2 sine delta x over 2. I need to divide through by delta x. Divided by delta x, divide by the whole thing by delta x. So the whole thing's been divided by delta x, which can then be written as delta y over delta x equals 2 cos x plus delta x over 2 sine delta x over 2 over delta x. That's that delta x, because these are multiple. So I can put that over here. Now I can rewrite this. So I'm just going to draw a line here so that I can continue on the right hand side. So if I want to make this delta x over 2 and this one to look like that. So if I divide this by 2, and I have to put 2 there. So what I'm saying is, if I divide that by 2, then I have to put 2 here. So the 2 cancel 2 is still the delta x. And that can be written as delta y over delta x equals 2 cos x plus delta x over 2 sine delta x over 2 over delta x over 2. And then there's a 2 here as well, which I need to not forget. There's a 2 there, but that 2, we cancel that 2. So that's what happened there. And now I have delta y over delta x equals to cos x plus delta x over 2 sine delta x over 2 over delta x over 2. Now, there is a limiting value which says that sine of theta over theta when we equal to 1 when theta tend to 0. So sine of theta, as theta tend to 0, sine theta becomes theta, and theta over theta is 1. So that's a limiting value. This value is very important to remember. It's one of the limiting values that we need to remember. And therefore, I could rewrite this now by saying, well, think of theta as delta x over 2. That's theta, and that's theta. So that will be 1. What that implies is that sine of delta x over 2 is theta over delta x over 2, which is that theta, and that will equal to 1 as delta x over 2 gets small in the limiting value. So as delta x tend to 0, delta y over delta x will tend to dy over dx, which implies that now we can write dy over dx equals cos x plus 0 over 2, as because delta x tend to 0, sine delta x over 2 over delta x over 2 tend to 1 times 1. Therefore, dy over dx equals cos of x. And that is the derivative of sine x. The derivative of sine x with respect to x is dy dx equals cos x. Just to remember that dy over dx can also be written as y dot, which is y dash, which can be written as f dash x, or sometimes is written out delta y over delta x, and that is change in y over change in x, which is the rate of change of y with respect to x. So sometimes we write it as the rate of change of y with respect to x, and that is dy dx. So the answer we're looking for is that for the derivative of y equals sin x.